All right, I want to spend a minute, not too long, but on the questions on those half sheets of paper.
I had no idea how to do this.
Okay, that's why we're spending time on it. All right, number 1 was 12. Number 2 was 15 over 8. Number 3 was 0.491. Those were just regular integrals. Number 4 was negative 6 over pi, because it was an analytical approach, not a calculator problem. Number 5 was x equals 0, or I guess you could argue c equals 0. And number 6, x equals negative 3 and negative 5, or c equals negative 3 over negative 5. Okay? I don't necessarily want to go over the front side because those are pretty straightforward. The only one on the front side that might be a little bit weird is number 2. How would you take the antiderivative of negative 4 over x cubed? You move the x cubed to the top, and then when you subtract 1 from the exponent, what do you get? Negative 2, not negative 4. Okay. But the back side, is there any questions on those? 5 and 6? So number 4 was pretty straightforward as well. It's just find the average value, right? Okay. Number 5 and 6, it was taking the mean value. Oh, we didn't talk about the mean value. It's taking the average value to the next step. Basically, the mean value theorem for integral says, okay, you found the average value, right? You know how to take the average value, right? The question is, where does it occur? Where does the average value occur on the graph? So let's look at that. F of x equals negative x plus 2. And we can look at it graphically, but we'll look at it both ways. If I want to find the average value, what's the equation for average value? From negative 2 to 2. What is it? The integral, negative 2 to 2. I'm going to put negative x plus 2 there, dx. What does that find? That's just the kind of the area under the curve, right? That is not the average value. What do I have to do next? 1 over. Okay, so that's the average value, right? So we'll say average value. So that's going to be 1 over 4 times the integral from negative 2 to 2 of negative x plus 2 dx. Now, there's a couple ways to approach this, but this is a constant, right? Remember what we can do with a constant? We can move it back in and back out, right? Okay, so keep that in mind. What's the antiderivative of this? Negative 1 half x squared plus 2x, and I'm going to put that in parentheses. Evaluated from negative 2 to 2, and then we have the 1/4 out front of that. Okay. Then I'll plug those values in, so you get negative 1 half of 2 squared plus 2 times 2, that's in parentheses, or brackets, minus negative 1 half of negative 2 squared plus 2 times negative 2. And then I still have 1/4 out front. You guys okay with this so far? Okay. That's 4, so that's negative 2 plus 4 minus, is that negative 2 again? Minus 4. And then we still have the 1/4 out front. That's 2 minus negative 6. So that's 8. So 2. That's the average value. That's not what I wanted. How do I find, when it says find the value of c that satisfies the mean value theorem, we're saying where on the curve does the graph equal the average value? So graphically, if we're going to look at this graphically, you have something that looks like that, right? You guys okay with that? I'll answer that in a second. So this is at 2 here, and this is at negative 2. No, this isn't right, is it?
Yeah, that's the graph.
I graphed that wrong. Okay, whatever. So this is at negative 2. The value is what? 4. Okay. So that's the interval we're looking for. Finding the integral, just the integral, what are we doing? Taking the area under the curve, so that would be 1/2 of what times what? 4 times 4, which is 8. That's the area under the curve. So that's the area under the curve. What do I have to do to find the average value? Divided by the width, which is 4. That's where we get the 2 from, right? But the mean value theorem says there is a point somewhere on the curve that matches the average value. So the average value function is 2. So that means this is the average value function. So where does the curve equal the average value?
0.
When x equals 0.
I'm confused. Back up to the 1/2, 4 times 4 equals 8. Like, what did you get?
The area of the triangle. So 4 is the width. And
Oh, yeah.
I was just showing another approach to getting this integral, the graphical approach to getting the integral. So analytically, from here, what would we do analytically to show the mean value theorem? We would say, when does the average value equal the function? So that would be 0 equals negative x, or x equals. Okay? No, we missed that slide. Look, it's very simple. You find the average value. Once you find the average value, what do? You set it equal to the integrand, and that tells you when the curve matches the average value. Okay?